Problem 35 on page 466. Skittles. I'm curious, how many people would rather have Skittles than regular M&Ms? Peanut M&Ms? Caramel M&Ms. Your favorite M&Ms? Still Skittles? Okay, most of you still have. All right. I think you're wrong, but hey, that's okay. So this problem says that the makers of Skittles claim that 20% of Skittles candies are orange. 20% are orange. That is our claim, company's claim. And the problem goes on to say that you select a sample of 30 from a large bag. How big is a large bag? I think a large bag in my mind is bigger than like your king size. It's like what you have to go down to the candy aisle for. Right, one of the big bags. Or, I mean, a large bag could be a whole pallet of Skittles, right? You ever seen the pallet bags? Maybe not of Skittles, but it could be. That would be pretty awesome if you like Skittles. Okay, that might give me enough to want to share with somebody. And it asks, or it says p hat is the proportion of orange. It doesn't really ask it. It says it's the proportion of orange in the sample. Okay. So that's the data. Those are the notes I'm putting down for the problem. It says identify the mean of the sampling distribution of p hat. So that's asking you, what's the mean of p hat? The mean of p hat is p. It's 20. Yeah, it's 20. It's the claim. It's 20%. All right. They claim it's 20%. We believe them for now. Maybe we don't believe them later. I don't know. So the next thing, it says calculate and interpret the standard deviation of the sampling distribution of p hat. Verify that the 10% condition is met. So is 10% of our population of Skittles in our large bag greater than 30? So another way of phrasing that is, do we believe that there are more than 300 Skittles in our bag? Is that reasonable if it's a large bag? Yeah, I think so. Okay. So we're going to say this is reasonable to assume. Right.
That's going to change for every problem that we have.
It's something you have to consider for the problems, the proportion. Yeah, you have to consider it. So if this isn't true, then we can't find the standard deviation. Usually when they say from a large something or another, when they say that the population is large, you can assume that that's been met. It's a safe assumption. Okay. So because that's true, I can go ahead with sigma p hat, which is going to be the square root of 20%, 0.2, times 1 minus 0.2, all divided by our sample size of 30. So I get that this is about 0.073. Double check and see if you get that. Make sure you're working the calculator right. We have had, there's one calculator out there where I had a student do something like this. 0.2 times 0.8 divided by 30, and that student got an error when they put the fraction underneath the radical. I couldn't figure out why. So if you happen to have a calculator that doesn't allow you to do it that way, if you choose to do it that way, let me know. But you can just go square root of 0.2 times 1 minus 0.2, which is 0.8, and then just divide that by 30. That works as well. So the order of operations underneath is just fine in that order. Okay. All right. Now, C asks us, describe the shape of the sampling distribution of p hat and justify your answer. Oh, wait a minute, back up. I didn't interpret this. We have to interpret this. So I'm going to say that we expect our samples to vary by about 7%. That's what this would indicate. Mm-hmm. Kinda. So what that means is between our 1 standard deviation and our -1, we've got 68% of the data. So that's going to be, that actual distance is 7% roughly, 0.07. So our number of orange is going to vary normally about 7%. Well, if it's normal, right? So the next question is it normal? How do we check for normality? That's that large counts condition. So n times p. So that's going to be, 30 times 0.2 has to be greater than or equal to 10. And it's not, is it? Yeah, this is just 6. So our large counts condition fails. This is not a normal shape. I don't even have to do the other one. I don't know what it is, but it's not normal. Or we can't say that it's normal based on the numbers alone. How's that? How big would the sample have to be to meet this condition? It's going to have to be larger, but how large? It is, right? 20% of 50 would give you 10? Yeah. So this isn't part of the question, but if n equals 50, then this would check, and we'd have a normal situation. But your population would have to be 500, not 300, right? You'd have to make sure that you have enough Skittles to make that true as well. So, yeah, if the size was 50, we'd meet that normal guideline.